The chemical quantities and aqueous reaction in this part of the unit, we're talking about stoichiometry, which is the numerical relationship between the chemical from the reactant to the product side, or between the two reactants, or between the two products. Because the coefficients in the balance equation, it shows number of mole, and the mole ratio is fixed number after you balance the equation properly. So if you have a balanced equation, that counts like a recipe, and you can read the equation based on number of moles, like the equation we have on the board now. It says 2 moles of octane, 25 moles of oxygen gives 16 CO2 and 18 H2O. You probably noticed that it's a very common product of CO2, H2O. This is just for combustion reaction of hydrocarbons. So if you have like a carbon and hydrogen, your reactant is hydrocarbon, carbon and oxygen. And then you combine it with oxygen. That's the type of reaction is called combustion reaction. Combustion of alkane, it gives carbon dioxide and water. And when you balance this equation, every carbon gives 1 CO2, and every 2 hydrogen, it gives 1 H2O. That's like in general. So if you have 2 times 8, that's 16 carbon, gives you 16 CO2. And you have 2 times 18, that's 36 hydrogen, it gives you 18 H2O. Just an observation that I thought it might help you. So from the stoichiometry, you can predict how much of reactant is needed or how much of product is formed. But you must have always like given and looking for. So when you read a question, look for those 2 terms. What is given, what is looking for? A given that is very valuable is a balance equation, because that's your recipe. If you don't have it, you cannot answer any stoichiometry question. It says how much CO2. So this is looking for. Label it, looking for. Okay, from 22 moles of octane. So this is given. You always start with the given, which is 22.0 moles of C8H18. You want to multiply by conversion factor that you end up with the looking for. Okay, your conversion factor, it should be composed of what you are looking for and what is given. The given needs to be canceled. So we want to say C8H18 down here because it needs to be canceled, and we are looking for CO2. Well, these are just the symbols. What are the numbers? The numbers are coming from balance equation. You just fill in these numbers from coefficients from balance equation. Every 2 C8H18, it gives 16 mole of CO2. And if you get this canceled, you can do the math and end up with moles of CO2. Okay? You get moles of CO2. Just do the math and you get the moles of CO2. That's 176 moles of CO2. If you have any questions, you can stop me. You can ask your questions, please. Okay, another example, estimate the mass that is produced, combustion of 3.4 times 10 to 15 gram of gasoline. That is a high number, but if you have a calculator, that should be no problem, right? So I told you when you are looking at the mass, you want to first go to mole. Always go to mole first, okay? So still, what is given? Given is the gasoline, and that's the same thing as this C8H18, okay? Gasoline, assuming that this is the gasoline, that's what we have. So looking for is the mass of CO2. So you start with the given, 3.4 times 10 to 15 grams of C8H18. A mass to mass ratio, it's possible, but is not very convenient to work with. It's better to convert to mole first. So this is mass. For stoichiometry, I suggest you change to mole first. So you have to do, convert that to mole first. So you need the molar mass. I'm looking for the molar mass for that, for the C8H18, so you don't have to convert, you don't have to calculate it. So the molar mass for C8H18 is 114. So that's the 1 mole of this. So you convert the mass of gasoline to moles of gasoline, and you say 1 mole of this gasoline is 114.2 grams. So now you have the moles of the gasoline. Then you want to convert that to moles of CO2. And
Professor?
yes.
How do you know if how do you know that 1 mole for C8H18 is 114.22?
Good question. Let's calculate that. We have H18. To find the mass for 1 mole, basically you're calculating molar mass. And in order to calculate molar mass, you need to have your periodic table handy. So this compound for every mole contains 8 carbon. So carbon, you have 12 grams. Each carbon is 12 grams, but since you have 8 of them, you have to multiply by 8. And then the mass contributed from hydrogen, you have 1 gram, but you have 18 of them. So it's going to be times 18. So 12 times 8, that's coming the mass coming from carbon. 1 times 18 is the mass coming from hydrogen. And if you add, you multiply these and then add them together, it gives you 114. And that is gram per mole of C8H18. So if you have the chemical formula for C8H18 and you have periodic table, you can come up and calculate this number. Yes, unless it's given to you. If sometimes they do a bunch of calculate the molar mass, and then one question says, okay, here is the molar mass, do the rest of the problem. So if you convert the mass of the C8H18 to moles of C8H to moles, next step, you want the moles of CO2. So moles of CO2 is CO2 over C8. In order to find the moles of product or moles of what is looking for, we need a ratio. And that ratio is coming from balanced equation. We can write these the letters. We know that this is given and we wanted to cancel it, so it has to go to denominator, and CO2 is looking for, so it has to stay, so it goes up, so we don't cancel it. But these numbers, they come from balanced equation. Do you remember those numbers? I think it was 2 and this is 16, right? 16 and 2. So 16 moles of CO2 for every 2 moles of C8H18. So now we are getting from balanced equation, we don't get the mass, we get the moles. So basically, this numbers that is coming from balanced equation is the moles of CO2. And this is the moles of that. But the question is not asking for moles of CO2. We have to convert that to mass. So we want to get to the gram of CO2. And we want to cancel the moles of CO2. What is the number that relates mole to mass for CO2, same compound? What should I use?
Molecular formula, I mean the grams.
Yes, molar mass. 44 grams of CO2 is 1 mole of CO2. And then when you do the math, you see that we are canceling the moles of CO2, we cancel the moles of C8H18, and we end up with the gram of CO2. And if you do the math, so you end up with a number that shows gram of CO2, and to avoid using calculator, I can show you the number that it was produced here. Okay, 1 times 10 to 16 gram of CO2. That was the amount that was canceled. And when you watch this, if you download the PowerPoint presentation, you can basically do like a step-by-step, like I did. Like every time you click, it shows you the next step, so you can build it skills how to solve the problems.
Professor.
Yes.
So you might have explained it, but how did you find the 16 moles of CO2?
Okay, it was coming from balanced equation. It was in the previous slide, and I said, does anyone remember? Because I remembered, but it was coming from balanced equation, because the balanced equation is a key. You must have the balanced equation to begin with. And if you look at this equation, it's very similar. Okay, what is given here? Can you tell me what is given?
9.0 gram of glucose.
This is the glucose, so we know that this is given. And what is looking for? Water, right? It says how many milliliters of water. So this is looking for. Do we have the moles of it each? We don't have the moles, right? We have the mass. So what should be our first step? We want to change the mass of given to moles of given. When we have the moles of given, we want to use the balance equation and convert that to moles of looking for. When we have the moles of looking for, then we answer the question. Can you write these 3 steps or 4 steps? First, have balanced equation. If it's not given, make sure you balance it. Second, if the mass given for given, change that to moles for given. Then use the balance equation to change the moles of given to moles of looking for. Then you answer the question. Okay, so remember the ratio here is 1 to 6 because you need that ratio. And in order to go from mass of glucose to moles of glucose, what do we need? We need the molar mass for this. Okay, we need the molar mass, and the molar mass for glucose is 180. It's given here, but if you don't believe it, just add 6 carbon, 12 hydrogen, and 6 oxygen together. It gives you 108. So we start with 9 grams. We start with the 9 grams of glucose, and we multiply by the conversion factor to change that to moles of glucose, and that is 1 mole, 180 gram, or 1.8 times 10 to 2 gram. So we have that number of moles of glucose. From balanced equation, you get the moles of water, and then you answer the question. The question is how many milliliters? There is no conversion between mole and milliliter, but first you go to mass, find the mass of water. And since we know that every gram of water is 1 milliliter, the mass and the milliliter is going to be equal, but you have to show your work and say that this is the unit. You want to make sure that your unit is properly addressed. So you have mass of the given converted to moles of given, moles of looking for, mass of looking for, and then you answer that question.
Professor?
Yes.
Is 1 milliliter over 1 gram common knowledge that we should know?
Yes, density is 1 for water. Yes.
Density, okay.
Density for water is 1. That means 1 milliliter of water equals 1 gram. Yes, good question. For water, you don't have to know the density for everything, but for water, yes. Okay. What is limiting reactant? You do have a question about the limiting reactant in the exam. So you need to know about how to find the limiting reactant. What is limiting reactant? Is the compound that is going to be consumed first, is the compound that determines how many of the product we can make. Let's say if you want to make a simple sandwich or cheese sandwich, and for the cheese sandwich, you need 2 slices of bread and 1 slice of cheese, right? For every 2 slices of bread, you need 1 slice of cheese. Now, if you have 9 bread and 4 cheese, which one is the limiting reactant here?
Cheese.
Cheese is going to be limiting reactant. So if you have 8 bread and 5 cheese, which one is the limiting reactant?
Bread.
Bread. How? Based on the 2, you have to have your balance equation first. So you need to know that 2 bread plus 1 cheese is going to give you 1 sandwich. So based on this ratio, you always need the 2 bread for every cheese. To calculate the limiting reactant, you can find the number of moles of each reactant first, and then you divide there are a couple methods, okay? Whichever you feel more comfortable, you can go with that. You can say each one of them separately, how much, if you use all of these breads, how many sandwiches can you make? It's going to be 4, right? If you have 8 bread, would give you 4 sandwiches based on the balance equation. If you have 5 slices of cheese, then it gives you 5 sandwiches. The one that produces less product is going to be limiting reactant. That is one way that you can use, okay, to find the limiting reactant. Limiting reactant is going to tell us how much product we are getting, because if you have an extra slice of cheese, you cannot get sandwich, and is not going to count as sandwich. It's just you have excess compound. How much of the excess compound is going to be left over? Then limiting reactant tells us we can only make 4 sandwiches. And if you have 5 sandwiches, there would be 1 leftover. Oh, I'm sorry, 5 slices of cheese, there would be 1 leftover slice of cheese, because you can only make 4 sandwiches here. The percent yield is also another term that we deal in this quantitative analysis. The actual yield is what you find in the experiment. The actual experimental, what you find in the lab or was found in the lab, you have to look for those key terms. Theoretical yield is what we can find on the paper based on using all limiting reactants. So if the limiting reactant is consumed entirely, you can come up with the amount of the product that is possibly formed, and that amount of the product that is possibly formed is called the theoretical yield. In a reaction, when you do actual reaction in the lab, there is some loss. So experimental value sometimes is less than the actual value. Sometimes the experimental value is more, and that's not very common. But let's say if your compound is not pure enough, you have to dry the sample, you didn't dry the sample, you can get higher percent. But if you get higher percent or lower percent, there still is a percent error you have there. So percent yield is how much you got from expected value. So expected value is shown by the theoretical value, or how much product you get if you consume entire amount of the limiting reactant. To calculate percent yield, actual yield divided by theoretical yield is going to give you the times 100, it gives you the percent yield. The limiting reactant for this reaction, it's best to calculate that based on number of moles. And based on the number of moles, you can calculate. So you have to be given quantity. So for every 1 mole of CH4, you have to consume 2 moles of O2. So if 1 mole of CH4 is given and 3 moles of O2, there would be leftover of O2. So CH4 would be limiting. But if 2 moles of CH4 is given and 3 moles of O2, then 2 moles of CH4 needs 4 mole of O2. As a result, your O2 is going to be limiting. So with some examples of that is given in this slide, it just helps you to determine and visualize which one is the limiting reactant. So if you have 5 CH4 and you have 8 of the O2, that's the same thing as I said, that you have 5 slices of cheese and you have 8 slices of bread. Which one is going to be the limiting reactant? What would be left over? So whichever gives you the least number of product, that would be the limiting reactant. Yes. Your question?
No, I was just answering the question. I think it was oxygen.
Yes, it was oxygen. Perfect. So we have plenty of examples that here it shows you what is the limiting reactant and how to find the theoretical yield and the percent yield. Okay, so what is the first step? Can you tell me what's the first step? The first step to do any stoichiometry problem,
Balance the equation.
To have a balanced equation, because if you don't have balanced equation, you cannot, your numbers are not going to be accurate, is not going to work. Then after the balance equation, what would be your next logical step? Is to read the question carefully, find what is given, what is looking for. What's given, what's looking for, are they in the mole unit, or the unit is in gram or kilogram or what? Your best starting point would be to change them to mole, to change the reactants to mole. And if you have them in mole, it's going to make it much easier for you to deal and see which one is limiting, which one is the excess compound. So the given quantities, these are the given quantities. Which one is the actual value here? What is that, the actual value? How do you know is the actual value? What's the keyword?
Produced.
Produced, or it says obtained. In the problem, it says obtained, right? Obtained. It doesn't say this is the theoretical value. If it doesn't emphasize that this is the theoretical value, that means it is actual value, or it's experimental value, or what is produced in the lab. So if you identify your given, you're looking for, and then you are going to, in this case, you are given 2 quantities. And if 2 quantities is given, you have to decide, well, which one is going to limit my reaction? If quantity only for 1 is given, that is the limiting reactant. You don't have to search for limiting reactant. If quantity for 2 reactant is given, then you have to search for limiting reactant. Which one is the limiting reactant? So you have to find the limiting reactant. So when you have the kilogram, first you want to go to gram, then you want to go to moles, because we said if we have the mole, it's much easier to deal with, to find the limiting reactant. Okay, the other method, like other than going like how much product is going to give you, if you have the mole, this is another method to find which one is limiting reactant. When you have the mole for each reactant, divide that by the coefficient from balanced equation. Okay, so if you divide that by coefficient from balanced equation for each one separately, The one that gives you smaller ratio is basically the one that gives you the lowest amount of the product, and that is the limiting reactant. So if you felt more comfortable with the other one, find how much product you get from each one. The one that gives you a smaller amount of product, that's like killing two birds in one stone also, because then you have your theoretical value as well. This step, you can do it and it works. For like high school students, this one works a lot more because they want to follow the steps. But for college students, I think if you go the other way that I said, find the amount of product formed by each of the reactants separately, that's like takes you one step further. So we already know that the product of, okay, in this case, whichever is given the smallest amount of the product, do we have the numbers, or is just still the concept? You need all the molar masses. You need the units for kilogram to gram. And you want to convert you need to know the mole ratio for, that's what, when you're trying to find how much of the product is going to form. See, I'm missing my balance. Okay, balance equation is given here. TiO2 plus 2 carbon, that gives 1 Ti plus 2 CO. So we had 28 grams of 28.6 kilogram of the carbon. First, we convert to gram of the carbon. Then we convert to moles of carbon. And then the product that is going to give you, the amount of the product that is going to give you, if you use all of the carbon, is going to be 1.1 times 10 to 23 mole of Ti. So you want to see which one gives you more moles of Ti. The TiO2 convert to mass, the mass from kilogram to gram first. Then you convert to mole, and then find out how much of the product you're getting if you use the entire Ti. Which one is the limiting reactant? The one that gives less mass of Ti, because Ti is the product. So which one is the limiting reactant in this case? TiO2 or carbon?
TiO2.
TiO2 is the limiting reactant. So we already have our limiting reactant, and limiting reactant is going to give us how much of the product we are going to get. So we have the mole of the Ti, and if you have the moles of Ti, you convert that to mass of the Ti. This is theoretical yield. So when you do the calculation based on consuming all of the limiting reactant and convert it to the product, you can get the amount of the actual or the theoretical value or the product produced based on the limiting reactant, and that is called theoretical value. So if you have your theoretical value, you also were given the amount that was produced, the actual value, the actual divided by theoretical times 100, it gives you percent yield. If you subtract this from 100, that gives you percent error. That's how much you have lost. Does it make sense that to get 52.9 grams of the product, you are using 86 grams, you get 52 grams. This is just checking your answer. Does it make sense or not? Yes, it does make sense because the molar mass for Ti is less than TiO2. So okay, can you follow this next equation yourself? See what you can, what you need to start with, what is given. Do we have to determine the limiting reactant or not? Do we have to determine limiting reactant?
It doesn't ask that from what it seems.
Yes, but is it understood in the question that you have to determine limiting reactant?
Yes.
Under what condition you have to find limiting reactant?
Yeah, because you have to
Whatever's
find how many
available.
grams of N2 can be. Right.
Okay.
So you need
The
limiting
correct answer
reactant
for
to find-
that, you have the understanding, but I just want to put on the record that if the quantity for 2 reactant is given, you have to find limiting reactant. If the quantity for 1 reactant is given only, you don't have to find limiting reactant. In this problem, quantity for ammonia is given and quantity for copper oxide is given. So since the quantity for 2 is given, you have to find which one is limiting reactant. What are the steps? Step 1, balance equation. Balance equation is given. What's the step 2?
Well, you could take nitrogen and then convert that into moles.
Both of them, both reactants to moles, not the nitrogen. Nitrogen is looking for, but you need to convert.
Sorry. Yeah, sorry, not the nitrogen. The ammonia.
Yes, ammonia. Perfect.
Sorry, yeah.
So you want to convert ammonia to moles. So 9.0 gram of ammonia is given. And how do you convert that to mole? We know that we have to change that to mole. So mole goes up, right?
Yeah, and then the
Imagine.
molar mass goes at the bottom to cancel.
17 grams of NH3. Okay, perfect. So we have the moles of the ammonia.
Right,
And
and
then
then you're going to multiply it by the mole to mole ratio.
mole ratio of the nitrogen, because we already know we are dealing with nitrogen. So let's look at the nitrogen. For 1 N2, we have 2 NH3.
Yeah.
And since it's asking for gram of N2, we can do more. We can do more in one setting. So, so we have the mole, and we want to change that to mass of N2. What would be the mass for 1 mole of N2? 1 mole N2 needs to cancel, so it goes down. The mass for N2 is 28 gram. That's for every mole of N2 is 28. Periodic table. Anytime you see a ratio that is not given in here, that's coming from periodic table. So if I label these, okay, if I label these, where it's coming from, this is coming from periodic table, PT. This is coming from periodic table, PT. This one is coming from, this is coming from balanced equation, okay? So balanced equation, we get this one. But going from mole to mass or mass to mole, we use the ratio from periodic table. So you see, like, you only given like 9.9. Where do you get all these numbers from? So make sure you know that you have periodic table and you have a balanced equation. If you want to go from mass of reactant to mass of product, you need 3 conversions. You go from mass of reactant to mole of reactant. You go from mole of reactant to mole of the product, and then from mole of product to mass of the product. Next, we have 45.2 grams of CuO. We want to convert that to mole of CuO. Can you tell me what's molar mass for CuO? 64 plus 16, that's 80.
She didn't have to do that. I was gonna get my calculator.
Okay, 80 grams of CuO. And then we want to see what would be the number of moles of N2 that we are getting for CO? For
Oh wait, that's
one
copper.
N2, we need
I
3
read that as
CO.
calcium.
Is a Cu 64. Yes,
Yeah. Sorry, it looked like an A
that's it.
at the
Sorry.
first part.
And then if we have this, we are going to change that to gram over 1 mole of N2. Can you, if you have your calculator out, can you give me these numbers? I don't think I have them in the.
Divided by 3.
Okay, give me the first number quickly. So do 9 times 14 divide by 17.
So the bottom number, 45.2 grams, is equal to 5.27.
And the top one? Thank you.
7.4.
7.4 gram of N2. So which one is the smaller value? Is this one. As a result, CuO is the limiting reactant. This is coming from limiting reactant, okay? And this value, because it's gram of product, also is known as theoretical yield. You see, you kill two birds with one stone. That's also known as the amount of the product coming from using limiting reactant is the theoretical yield.
Why is that considered the theoretical yield, and why isn't the top number 7.4 considered?
Okay, theoretically, you cannot make 5 sandwiches if you only had 8 slices of bread. Because before you're going to have some leftover of ammonia, but CuO will be consumed, and as soon as CuO is consumed, the reaction is going to stop. So that's the meaning for limiting reactant. Limiting reactant would stop the reaction. It gives you this much of product and then it stops. And that's theoretic. That's the theoretical value. This is even the theoretical value, and that's all is asked. I mean, if it was additional question, like what is like percent yield and all that, you could have, or theoretical value, what's theoretical value, you could have answered this. But this is the amount of the nitrogen that is going to produce, because CuO will be consumed and it will stop. The reaction will stop.
I have a question. I have 2 questions actually. So my first question is, if they were to ask for the percent yield, they would give you the actual yield?
Exactly. Yes. If they say like there were 5 grams of N2 produced or obtained, what is the percent yield? Then you could do 5 divided by 5.27 times 100. Yes. Good question.
And my next question is, sometimes, so are we supposed to assume that, like, let's say nitrogen is a diatomic molecule, or so this question,
nitrogen is always diatomic molecule. That's how it exists. And if the balance equation is given to you, it's going to make your job easier.
So yeah, in the question here, it gives you how many grams of N2, and then it tells you gas, obviously. So if it says how many grams of, and it spells the word out, nitrogen, are we supposed to know that nitrogen is?
Exactly. Good point. Very good point. Yes. You're supposed to know that nitrogen is a diatomic. There are 7 of them. And 7 of them is like, have no fear of iced cold. What is this? Butterbeer? Okay. H2, N2, F2, O2, I2, Cl2, and Br2. These are diatomic, and you cannot write them as N or O or I. There are 7 of them. And then if you look at the periodic table, they are like this. You have nitrogen, oxygen, and then you have fluorine, chlorine, bromine, iodine. Okay, then you basically in the periodic table, if you draw number 7, it would cross these 7 atoms, and those are the 7 diatomic molecules. And you have to memorize them. And you can use this memory trick or the other one. Plus hydrogen. So if you do 7, make sure that you include hydrogen. Okay, any other questions? No? Okay. So this PowerPoint, as I said, it meant to give you a step-by-step solution. So it's helping you to find the answer like step by step. That's why we are jumping by like 10 slides. Now, there was a question about net ionic equation. I just have to make sure that to address that. In order to write net ionic equation, we need to learn about solubility, if the compound is soluble in water or not. And if a compound is soluble in water, is going to give ions, produce ions if it's soluble. So you learn about the solubility rules. These compounds that they contain group 1A or nitrate or acetate, they are going to be always soluble. Compounds containing chlorine, bromine, and iodine, they're soluble with some exceptions, like silver chloride is not soluble, lead chloride is not soluble, mercury 1 chloride is not soluble. Sulfate are soluble. So it's something that a table would be provided unless there is no exceptions. So if there's no exceptions, you are expected to know. If there's exceptions or lots of exceptions, you don't have to memorize it. And just be able to use it. What does it mean? Hydroxide are insoluble. So if you say copper hydroxide, it would be insoluble. How do you know copper hydroxide is insoluble? It doesn't say in this table. Well, it says that if you have lithium hydroxide, it's going to be soluble. And if you have sodium hydroxide, it's soluble because there's exceptions to insoluble rule. But if you have copper hydroxide, it would be insoluble and you have to write S. So anything that is not showing in this table is going to be, as exception, is going to be insoluble. Like sulfide, if you have zinc sulfide, is going to be insoluble because zinc is not in this table for exception. But if you have lithium sulfide, it would be soluble. And if it's soluble, you will indicate AQ. That's for soluble. S is designation for not soluble. So as long as you know how to read these tables, that's the first step. Okay, I didn't answer your question about the net ionic equation. I don't remember who asked me, but are you still here? Do you still have a question about it?
Yes. That was my first question I asked.
Okay.
I just wanted to make sure that I mean, if you didn't emphasize it in those slides and it's not going to be on
You see, right after the solubility rule, it goes to like double displacement reactions that would give you ionic and net ionic equation. I want to make sure it's covered and is recorded. Maybe I didn't have the slides still. I was working on it. I'm constantly working on these, but let me just give you answer to your question that would cover the ionic and net ionic equation. So let's say we have silver nitrate, okay? Silver nitrate, because it contains nitrate, anything that contains nitrate, that was no exceptions, is going to be AQ. That means it's soluble. Plus silver nitrate plus, just going to make it very simple, and I give CaCl2. Okay, not too simple, but simple enough okay, is going to give you products. You have two aqueous solution, and in order to predict and write the product, you can say, okay, this is double displacement type reaction. And if it's a double displacement type reaction, cation from one is going to go with the anion from the other, and the anion from one goes with the cation from the other. The other way of writing, simple, it says in, out, out. What does in, out, out means? It means the same thing. Cation from the second one goes with anion, and out, out, cation from one goes with the anion from the other one. But you have to be able to write the formula because you learned that in unit 4. So we know silver has a 1+ charge, and nitrate is a 1-, calcium is a 2+ charge, and chloride is a 1-. So when we are bringing to the other side, we have to keep that in mind. It's going to be AgCl plus CaNO3 2. Okay, and then we have to balance the equation, and this is the balanced equation. Now, is AgCl AQ or S? The table for solubility said that if we had chloride, but if it was a silver chloride, it was insoluble. So we know this is insoluble. We have to say S. But anything that contains nitrate is AQ. So we have to have this equation is a balanced equation, and is known as the molecular equation. So this is known as molecular equation. Okay. Now, from molecular equation, you can go to complete ionic equation. And in order to go from molecular equation to ionic equation, what you need to do is to anything with the AQ changes to ion. If S, L, or G stay, does not change. So AgNO3, is it AQ or is S? AgNO3. What should I do if I'm writing complete ionic equation?
Separate them.
Separate them. And if I separate them, I have to know that from unit 4 that is going to change to Ag2+, and then NO3, I'm sorry, 2Ag+ and NO3-, 2 of them, because I have 2 of them. This is not going to make, the coefficient is not going to make a huge difference. I just don't want to be questioned what happened to the 2s. And then CaCl2, separate them, right? And if I separate, it's going to be Ca2+ plus 2Cl-. It's not Cl2-, because ion for chloride is a Cl-. So that comes from previous chapter. And what about AgCl? What should I do with AgCl? Can I change it to ions? No, because it says if S, L, or G stay the same, stay, not change. Not change. So we don't change to ions, okay? If it's solid, liquid, or gas, is not going to change to ions. It's going to stay. So AgCl is solid, is going to stay. Plus, okay, plus calcium iodide. So calcium is going to be Cu2+, and nitrate is going to be minus, but we have 2 of them. Okay. So I change everything that is AQ to ions, and this is the complete ionic equation. From complete ionic equation, I can change that to net ionic equation. And what is net ionic equation? In order to write the net ionic equation, I have to separate, I have to cancel everything that is identical and is known as spectator ions. So all of the ions are soluble in water, so I can put AQ for them. Anything is same on reactant and product side. Can you give me those, the list?
Solubility or amount?
Exact the same on both sides, reactant and product. Is Ag plus staying the same on the product side?
No.
No, so it's not
No.
a spectator. We have NO2 that is going to be
Yes.
canceled, right?
Yeah, that's
And
not the
then
same.
calcium,
Cancel.
cancel. And can I cancel chlorine?
No.
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 So after I cancel spectator ions, whatever is left is called net ionic equation. So I have 2Ag plus 2Cl minus, and that gives 2AgCl. This is called net ionic equation. And net ionic equation comes from, like, it's more of the precipitation reactions or double displacement reactions. When you have two compounds that they are soluble in water, you add them together, you predict the product. How do you predict the product? You would say in, out, out, or exchange of cation, exchange of anion. And then you write the formula, you check the table for solubility, and then from that table, you have to say, is this soluble or not? If on the table it says insoluble, you put S designation. For calcium nitrate, it's soluble because anything that has nitrate is soluble, and that's why we put the AQ designation here. Then in order to go from molecular equation to complete ionic equation, you are going to break all compounds that they are AQ designated. Anything that is AQ designated, you would break it to ions. Anything that is solid, liquid, or gas designation stays the same. It does not change. Do not touch them. Leave it alone. And then you have complete ionic equation. For net ionic equation, you go to the cancel spectator ions. Okay. There are other types of chemical reactions, but most likely they will be in the, most likely they will be on different units. I don't think that